Good morning and welcome to today's webinar. My name is Kira Proctor and I'm the Managing Director of the A Proctor Group Limited. And today, for our 8th 2021 webinar, we're going to take a look at radon protection measures in buildings. If you've missed any of our run of webinars over the past year, you can go back and check them out right here on our YouTube channel or through our Learning Hub at www.proctorgroup.com. You can also book in for follow-up calls with our team of experts or register for further information and physical copies of product information and samples. As always, we'll be following up with a live Q&A session with our team of experts, today hosted by Carol Michalak, with our special guest Michael Hancock, Director of the Glencoe Radon Gas Centre. Should you have any questions for our panel, you can type them into the chat box here, DM us on Twitter at ProctorGroup, or email us at webinar@proctorgroup.com. Radon is a topic that's becoming more important across the industry, having long been regarded as something that only affected projects in specific geographical areas. Experience is increasingly leading to a more robust approach to assessment and mitigation, drawing on lessons learned in these areas and applying them more widely. Although a failure to mitigate the ingress of ground gases such as methane and CO2 may have more dramatic consequences, radon has long been recognised as a quiet killer, with over 1,000 attributable deaths per year in England alone. So today we'll begin with a look at some background, what radon is and why we need to address it, before moving on to consider the applicable guidance and standards and how we assess these risks. We'll then discuss the protective steps taken and how we can ensure these are applied in a robust and effective manner, both initially and over the lifetime of the structure. This doesn't just mean verification of the initial installation, but also what longer-term monitoring may be required and how any emergent risks can be dealt with. Radon is a naturally occurring, colourless and odourless radioactive gas. It was discovered in 1900 by the German physicist Friedrich Ernst Dorn, who was studying the radioactive decay of radium, itself only discovered by Marie Curie 2 years earlier. This work was expanded by the Nobel Prize-winning Scottish chemist Sir William Ramsay, who identified radon as the heaviest gaseous element, 9 times heavier than air. In ground gas terms, most radon is produced by the radioactive decay of trace amounts of uranium found in certain types of rock and soil. And as such, the levels of gas present are determined by the underlying geology of the site, as opposed to any historical usage or pollution. This type of geology is most common in areas with granite bedrock, such as southwest England, the Peak District, north east Scotland and Northamptonshire. Aberdeen in Scotland, being known as the Granite City, has one of the highest background radiation levels in the whole of the UK. Regardless of geology though, we are all exposed to a certain degree of radiation from a wide range of background sources, both natural and man-made. The radon level in an average UK home contributes around half of our typical exposure, and this level is quantified in becquerels per cubic metre. Legislation requiring action against radon in UK buildings has been in place since 1985, initially for workplaces, but has since expanded to include housing. The average household radon level is 20 becquerels per metres cubed, and even at levels up to 100 becquerels per metres cubed, individual risk remains relatively low. However, if the level goes above 200 becquerels per metres cubed, then remedial action is required. Radon is harmful to humans as the radioactive elements formed by its decay can be inhaled into the lungs, where they continue to emit harmful alpha particles. These alpha particles cause localised damage to the lung tissue, leading to the development of lung cancer. The British Medical Journal estimates that around 1,100 deaths per year are directly linked to in-home radon poisoning, making radon the second largest contributor to lung cancer rates behind smoking. Some sources indicate that at least 1,200 new-built homes per year will be above the safe level of radon exposure and should have remedial action taken. This has in turn led to suggestions that building regulations may need to be updated to include more widespread radon protection. The first step to ensuring that an unsafe concentration of radon is not reached is to understand how the gas enters buildings. There are 7 main routes of ingress for radon, or for that matter, any other ground gas. Through cracked or porous solid floors, through junctions and joints between components, through cracked or porous below-ground walls such as in basements, through gaps in suspended floors, through porous walls and foundations, through gaps at surface penetrations and pipes, and through cavity walls. Because of the geological origins of radon gas, there is generally very little scope to remove or neutralise the source of the gas, so barrier and venting solutions are most commonly employed. Limiting the extent of the ingress paths here can, however, help by reducing the long-term resilience on a barrier and providing additional protection. It's also important from an energy efficiency point of view that airflow through the heated envelope is reduced as far as possible, so minimising the overall porosity of the building fabric should always be a priority. The principal source of radon guidance in the UK is the BRE document, Radon, Guidance on Protective Measures for New Buildings. This document is referenced in Approved Document C for England and Wales, Section 3 in Scotland, and Technical Booklet C in Northern Ireland. There is also extensive guidance available from the Public Health England's ukradon.org website. There you can find help and guidance for householders, employers, professionals, local authorities and housing associations. The distribution of radon producing geology is illustrated in radon maps distributed by Public Health England for the UK and the Irish Environmental Protection Agency. These maps indicate the radon risks associated with a specific location. It's worth bearing in mind here that though there may be issues with the available resolution of the geological data, the basic mapping will typically provide radon levels based on a 1 km by 1 km grid. While it can be in a lot of cases reasonably inferred that a clear grid square surrounded by other clear squares is unlikely to pose much of a risk, in areas with more complex and varied geography, it may be necessary to request a more detailed assessment of the local risk. For most areas of the UK and Ireland, more detailed graphic guidance is available on request. In the UK, the lead agency responsible for this is Public Health England, who also provide this information for Scotland, Wales and Northern Ireland. The Irish Environmental Protection Agency can provide guidance specific to the Republic of Ireland. This site-specific radon potential band determines the level of assessment and protection required. The radon potential band percentage represents the chance of any given building in the area having a radon level at least as high as the required action level of 200 becquerels per metre cubed. The low-risk areas with less than 1% chance of exceeding action levels do not require any special measures to be taken. Sites between 1 and 10% are classed as medium risk and require a basic level or protection, with sites over 10% being high risk and require full protective measures. On medium and high risk sites, testing and monitoring are also advised, which again is due to the highly localised nature of radon requirements, particularly in areas where different classifications meet, or sites which are on the borderline between risk categories. We'll move on to look at the various measures in detail shortly, but the most basic protection level typically comprises a radon barrier membrane within the floor or solum of the building, linked to a damp-proof course in the wall. These barrier systems should extend across the entire footprint of the building, and all overlaps and surface penetrations should be fully sealed. Moving to full protection requires the same basic level barrier system, but supplements this with additional ventilation to increase the rate of gas exfiltration. Depending on the level of risk and the precise configuration of the subfloor and foundations, this ventilation system may be active or passive and may require the use of sumps and/or mechanical extract fans. We'll now take a look at some of the protective measures in more detail. While it's certainly true that there are less variables to consider with radon protection than with some other types of ground gas or site contamination, it's still important to ensure the system is well designed and fit for purpose. Ensuring a barrier membrane system works effectively requires the material used to be suitably robust and the system to be well installed. Like other ground gas protection measures, the system is only as good as its installation, and if joints are not properly sealed or the membrane is punctured, then adequate performance cannot be guaranteed. A properly designed and fitted barrier will, however, also function as a damp-proofing membrane. The BBA requires radon barrier membranes to be at least 0.4 mm or 400 microns thick. It's important to remember though that membranes, if stretched, will become thinner, so ensuring the material has good tensile strength and elongation characteristics will make sure that the membrane retains its properties. When installed under a slab, for example, concrete poured on top can exert forces on the material, causing it to stretch and become thinner, creating a zone where the permeation of gas becomes more likely, even if the membrane is still intact and unbroken. Reinforced membranes made from virgin material typically have the best mechanical strength properties, thickness for thickness. While a thicker membrane can certainly work adequately, the additional weight and thickness can make detailing and handling more difficult. Joints in the membrane can either be taped or welded. However, in either case, appointing experienced and suitably qualified contractors is recommended. This ensures a good result is achieved first time without requiring remedial actions to fix any issues arising from poor workmanship. However the membrane is installed, it should be thoroughly inspected prior to covering, as fixing any issues after the membrane is covered is often effectively impossible. This inspection should look for any continuity issues such as unsealed joints, punctures, or areas where the membrane is not adequately supported, for example at boundaries where voids may cause excess elongation. Seals at all surface penetrations should also be inspected, as these details can be problematic on site, particularly if pipes are located near foundations or if installation took place under less than optimal weather conditions. Finally, although it may seem obvious, it's also important that the protective membrane and any associated accessories, such as DPCs, extend across the entire footprint of the building. This means from external to external, closing off any potential gas ingress points. This includes closing off any cavity walls with a suitably sealed and gas-resistant DPC material. Where it's necessary to move beyond a basic level of protection, ventilation should be introduced below the barrier membrane. This example shows a typical beam and block floor construction with a subfloor void. The gas-resistant membrane is placed over the beam and block subfloor and then screeded over. There are a number of systems and solutions for introducing ventilation to this subfloor area, such as ground-level vent boxes, telescopic vents through external walls, and simple air bricks. Exactly which of these solutions is most appropriate depends on the specific building envelope and relative locations of ground and finished floor levels. Provided the vent openings have sufficient open area to deliver the airflow required, they will also do a similar job. Where to position these openings to effectively negate gas buildup depends to a certain extent on the layout of the foundations and any supporting structure. While the best course of action is to discuss the size and location of vent openings with a specialist, there are some simple rules we can apply as initial guidance. Based on NHBC guidelines, vent openings should typically be placed at maximum of 2 metre centres along external walls and not more than 450 mm from corners. The relationship between voids separated by ground beams should also be considered. In ground-bearing slab applications where full radon protection is required, it's necessary to provide radon sumps to facilitate subfloor depressurization. The sumps and pipework are installed under the slab, with gas collected by the sump and ducted to an extract point above ground. This enables a subfloor depressurization system to be installed with relative ease at a later date, should it be deemed necessary post-completion. In a typical house, a single central sump is normally sufficient and will provide extraction over a radius of 9 metres from the sump, around 250 square metres. If the soil is particularly permeable, this may increase to a 15-metre radius, but this would require project-specific assessment. If the area under the slab is subdivided, for example with foundation beam or other compartmentalisation, a separate sump may be required for each compartment depending on soil conditions. At the minimum, pipes or air bricks in the subdivisions should be provided to ensure the sumps can provide adequate extraction. If multiple sumps are used, they can be connected with a manifold system and ducted to a single extraction system. This extraction system creates the depressurization that removes the gas. Most commonly, this is a powered or active system, where an electric fan is used to drive the extraction. While it's possible to use a passive system without a fan, active systems are more common. This is because the depressurization aspect of the ventilation system is generally only used if post-completion monitoring shows that it is required. If this is the case, a fan can easily be attached to the built-in pipework to provide this. Passive systems typically require more forethought and complex pipework taken through the building to high-level extract points to create a passive stack effect. In either case, however, it must be ensured that gas is extracted to a safe location away from opening windows and ventilation system intakes, with all pipe joints solvent welded rather than push-fitted. If a powered fan is to be used, it should be located as close to the end of pipe run as possible to ensure the pipework is kept under suction, in order to prevent any gas leakage in an unintended area. This is particularly important if pipework is to be run through the living spaces in a dwelling. Whatever the construction, if ventilation is required, it's important to ensure it's done right, as systems which are ineffective can lead to high gas readings and complex remediation. Conversely, an over-engineered system can increase timescales and costs with no particular benefit. At the A. Proctor Group, our experienced technical support team can assist in the specification of these systems, reviewing drawings and site investigations to ensure a suitable solution is specified and optimised to fit the individual project circumstances. While it may seem pointless to provide protection to an extension when there's none in the existing building, a subfloor depressurization system can help provide some degree of protection to the existing structure. By locating the new sump and extraction pipework adjacent to the existing structure and knocking through the existing wall, space for a sump under the existing structure can be created. The new depressurization system can therefore extract from both the fully protected extension and also from the existing unprotected structure via the two linked sumps. As well as the above-ground living space, it's important that any basements or occupied underground spaces are protected, particularly as these are at greater risk as gas can permeate not only through the floor but also through the retaining walls. For a typical domestic house, this means the areas in contact with the ground could be several times higher than for a similar house without a basement. This risk is further compounded by the lack of natural ventilation available in spaces below ground level. Alongside this, it's also important to consider waterproofing when creating a new basement or converting an existing cellar. Guidance and recommendations relating to basement waterproofing are given in BS 8102/2009, which also advises on the importance of considering radon mitigation when designing basements. In these situations, it's usually best to appoint a specialist to design and install the combined system, as radon and waterproofing requirements can sometimes conflict. If it's necessary to conduct monitoring of radon levels in a home, this is typically done by using detectors supplied by Public Health England. These detectors are placed in the home for at least a 3-month period to assess the level of radon exposure for the occupants. PHE typically recommend a year of monitoring for new homes in radon-affected areas, and this data can then be used to determine if active measures such as fans are required or if the basic level of protection is sufficient. This is not typically required for extensions. However, if substantial structural work is undertaken or the dwelling is in a particularly at-risk area, it is worthwhile considering. To conduct the testing, PHE-supplied radon monitoring devices are placed in representative areas of the occupied spaces and then returned to PHE for assessment at the end of the testing period. Generally, the detectors are placed in areas like TV stands or bedside tables to give an accurate impression of occupant exposure. They should not be placed in areas which are close to ventilation or windows, or in places away from the main inhabited zones in the dwelling, for example on top of a high wardrobe or on the floor. We'll now move on to take a look at some common installation situations and the difficulties that can arise with each. We've discussed this before in our webinar on brownfield sites, but installation quality is a critical part of ground gas protection, so it's worth repeating here. We'll begin with corner details, which are probably the most common detail present on every site. This corner has been cut and resealed using flashing, but it has been left unsealed at the corner. The membrane has also not been pushed into place properly, so any subsequent concrete or screed pours will overstress the membrane. This may lead to tearing and subsequent gas ingress. In this case, the membrane has not been extended to close the cavity wall, leaving an open pathway for the gas. The membrane is also roughly folded into place, which may cause problems when it comes to installing further courses of brick and blockwork. The most reliable and time-efficient method of getting a good corner join is to use a preformed corner unit. In most cases, however, these corners will need to be adapted to fit precisely into place. The important part of the corner, the integrity of the actual corner point itself, can be maintained by carefully cutting the corner unit across the middle and sealing both the top and bottom sections into place as shown here. This ensures the corner area remains fully gas tight. Another detail found everywhere is the simple membrane joint. Apparently simple enough, joints between adjacent runs of membrane commonly cause problems. The most obvious problem is the missing sections of sealing tape, creating a path for gas to bypass the barrier, but tape joints can cause other problems. Here we can see where the tape run has not adhered to the membrane, where the membrane is not sitting flat on the substrate. The most effective method, and that used by the majority of NVQ2 qualified installers, is to weld membrane joints. This not only saves on the cost of tape, but it is far more tolerant of weather and site conditions, as tape adhesion is not an issue. Successful tape jointing requires a clean and dry membrane surface to joint, and temperatures within the tape's operating range, typically 5 to 30 degrees. Assuming these conditions are met, the optimal procedure for a successful tape joint is shown here. By moving the butyl tape joints to the edge of the lap, it becomes far easier to ensure the joint has been done correctly. This positioning of the tape also ensures any concrete screed poured on top of the membrane cannot enter the joint and put additional pressure on the integrity of that joint. Detailing around stanchions is a little more difficult, but does not pose too many problems if the method here is used. The most important thing to note here is that the flashing tape used is of good quality and matched to the membrane utilised. As manufacturers, we recommend and supply tapes that we know work well with our membrane systems, and this advice should be followed. The flashing tape should be rolled into place without leaving gaps underneath. Flashing tapes are usually less resistant to elongation than membranes, so it's important these areas are fully adhered to a properly supported substrate to limit the potential movement. The rounded corners shown here are also important, as these are less likely to lift than a sharp corner and put much less stress on the membrane and tape interface. Although it may seem obvious, it's also important to ensure the gas-tight layer is continuous. If, as shown here, the stanchion is in the centre of a concrete column or pile cap, the entire area must be sealed. Pipe penetrations are another area it's important to get right, as they are a common feature on many sites. These images shown are of the more common problems that can occur. In the first case, the supplied top hats did not fit properly, so the installers have got a little creative. Whilst it's possible that this detail may work to provide a gas-tight seal, it is by no means a given and would be almost impossible to verify. In the second, the smaller pipe appears to have been relatively well sealed, but the larger is not sealed at all and corresponds to a lap in the membrane, creating additional complications. The close proximity of the pipes to each other also makes detailing and sealing using proprietary top hats difficult. Here we can see the correct procedure to provide a gas-tight seal to a pipe penetration, as with columns. This is not particularly difficult to achieve. Again, as with stanchions, ensuring the membrane is cut as little as possible and the top hat is smoothly seated onto the membrane is critical. The flashing tape should be firmly adhered in place and properly supported. The general conditions around a site are often as important as specific details when it comes to validation of membrane installations. In these images, you can see that patches have been applied to the membrane haphazardly and messily. The marker spray is still visible around patches, indicating that the applied patches are too small to give the required overlap. In this case, we can see the structural reinforcing bars laid directly onto the membrane with no protection fleece or board used. This protection is not only important to prevent direct puncturing of the membrane, but also to prevent damage from cutting using saws and grinders. These processes produce large amounts of sparks, which, if they contact the membrane, can melt holes and cause significant damage. So, whilst a small increase in cost per square metre to specify a fleece or protection board may seem unnecessary, the effect it can have in reducing remediation costs and delays is more than worth it in most cases. As with all ground gas protection systems, the critical aspect of detailing out radon problems is making sure the requirements are fully understood, and any implications are factored into every stage of the project, from design to construction, and finally to ensure monitoring if needed. A really important part of this is working with experienced project partners who are familiar with these problems and have a good understanding of how to solve them. With that in mind, we'll now move on to the Q&A session.
Good morning, everyone. Welcome to another sunny Friday morning. I hope everyone is keeping well and you're looking forward to the bank holiday weekend. Thank you so much for joining us. As Kira mentioned at the start of the presentation, this is our 8th webinar of 2021, and we are delighted that you've taken the time out of your day to be with us and stay for our Q&A session. My name is Carol Michalak, and if you have joined our webinar sessions previously, you will be aware that Kira, who normally hosts Q&A sessions, is now off on maternity leave. No news of the little one yet, but arrival is imminent, so fingers crossed, not long now. If you're new to our webinar sessions or you haven't joined us for a while, our format is that we aim to stay on here and answer all your questions. So feel free to post into the YouTube chat. You can send us a direct message to our Twitter page at Proctor Group, or you can drop us an email to webinar@proctorgroup.com. Now, if you can't stay on to the end, or you do simply need to leave early and you still have a question, don't worry. Please post it into the chat or send us an email and leave some details. We'll get back to you afterwards. If you have registered for today, and you still can register if you've not done so already, you will get a follow-up email from us with details on how you can watch the webinar back and also request a personalised CPD certificate. Please forward this webinar link on to any friends or colleagues that you think might find it interesting. If you'd like to see any product samples or arrange a virtual meeting with one of our team, please do get in touch. We'd be delighted to see what you get involved in and help out with any queries. You can also watch back any of our previous webinars. These can be accessed either here on our YouTube channel, or you can go to our website, www.proctorgroup.com, where we have a webinars and also a learning hub page with lots of content covered that you can watch back. Now, we really do appreciate you joining us for these sessions. And I'd like to ask possibly if you could just take a few seconds when you leave to give us some feedback. We say it all the time, but every bit of feedback does get read and taken on board. It helps to shape for future presentations and also lets us know if there's something in particular that has taken your interest. So leave a comment, give us the thumbs up, and subscribe to our YouTube channel, where you'll get notifications on everything that we're involved in, as well as future webinar content. Now that brings me nicely onto our next webinar, which is also available for registration on our website. This takes place 2 weeks today, Friday the 14th of May at 10 AM again. Topic next time round is air tightness solutions for high-rise and modular construction. If this is something you're interested in to know more about, please do sign up and join us again. So let's move on now to our Q&A session. Let me introduce you to our panel of experts for today. We have with us today Technical Director Ian Fairlington. Good morning, Ian.
Morning, everybody.
Good morning. We also have with us Pamela Howitt, who is our Senior Technical Advisor. Morning, Pam.
Morning, everyone. Morning, Carol.
Morning. And next we've got Sue Menure, who is also one of our technical advisors. Morning, Sue.
Morning.
And also we have a very special guest today. We have Michael Hancock, who's the Managing Director of Glencoe Radon Gas Centre. Now, Michael, I understand, has been working in the radon industry for around 16 years and has been involved with radon product development and installations across both the UK and France. He actually passed the Radon Council training course at 15 years old and has since invented his own cylindrical mini radon sump product. He manages large radon projects with the likes of Lloyds Banking Group, HSBC and BT, to name a few. And I am delighted that he has joined us today. Good morning, Michael.
Good morning.
Good morning. Now, we can see there's been quite a lot of questions come in already, which is absolutely fantastic. Do keep them coming in and bear with me whilst I collate them in from the various different sources. Okay, let's start with this one, which has come in on our YouTube feed, which, Pam, I will put to you if that's okay. Michelle Paul has asked, is there any difference in the number of sumps required for a non-domestic building compared to a domestic building?
Yeah, so I mean, generally the same criteria and rules will apply to all buildings, whether they're domestic or non-domestic. So you would normally look at a sump and the area that it would actually influence. So that's around about 250 square metres of floor area. There are potentials for economies to be made in terms of the number of sumps and the amount of pipework that can be provided or needs to be provided. Larger areas, rather than having individual sumps vented out, they can be manifolded, joined together to reduce the number of fans, etc., that may be required or that might be needed to be fitted in the future to control that radon. It also depends on what is going on subfloor. So if you've got a large void that's uninterrupted by dwarf walls or founds, etc., you may be able to get away with fewer sumps. But if you've got a lot of compartmentalisation going on subfloor, you probably will need to look at some sort of gas collection in each of those areas. So it really depends on your floor and the design of your foundations, etc.
Right, thanks, Pam. Okay, Sue, let's move to you now if that is okay. Joseph Masterton has asked on the YouTube feed, why do we tend to use the BRE 211 guidance over the BS 8485 2015 Annex A1 2019 when it comes to dealing with radon?
So like whilst BS 8485 is generally the go-to guidance when you're dealing with ground gases in general, it doesn't really take the issue of radon into consideration, however. So this is why we actually go and follow the guidance given in BRE 211 document. This is specifically related to radon gas. It's sometimes assumed, I suppose, that radon is a more insignificant gas compared to the likes of methane or carbon dioxide, for example. But it's really important to understand that radon gas, it can be very dangerous. It's known as the silent killer. So therefore, thoughts of protection should be taken really fairly early on in your design stage. And that's really just to ensure that you have a robust and workable system, ultimately.
Perfect, thanks, Sue. Okay, let's move on to one. Ian, if I can bring this one to you. Craig Thompson has asked on YouTube, there's perception that 1200 gauge standard DPMs can provide adequate radon protection. What is your view on this in relation to robustness?
Okay, thanks, Carol. 1200 gauge polythene, not a great fan, to be fair. I don't think it's a great specification for damp-proof membrane, never mind a dual function of both radon and damp. I think that might be an old specification. Things have moved on. Certainly, in terms of BBA, for example, BBA are now requesting that the membrane be at least 0.4 millimetres thick, rather than the 1200 gauge, which would be 0.3. Especially being unreinforced, you've got to think about robustness. 8485, which Sue mentioned earlier, and we've just had a question on it, I do have a degree of problem with the fact that it's only looking at thickness and weight for a membrane, where I don't think that's necessarily a good measure for robustness. You've got to look at the whole robustness, and unreinforced membranes, whilst they can be really effective, they can be, you can make them too thick that they're unhandleable, as it said in the presentation earlier. So I think you have to be very careful and not take just the weight into consideration. And if you are looking at the weight, certainly more than 1200 gauge, please, more than 1200 gauge. Now, Michael might be able to add more to this with his experience, whether this is just a personal gripe of mine or whether Michael might have some views on it.
I think no matter what thickness of barrier you have, you're still going to have radon passing through the barrier. So obviously the thicker the better. Obviously it needs to be workable around the corners and forming in. I don't think 1200 gauge is thick enough personally, and they should be reinforced barriers if installing for radon. If you don't seal the barrier properly, obviously as said in the presentation, 99% of your radon will go through the barrier. You will lose all your protection if you have one pinhole anywhere in your barrier, no matter how thick it is. So it's worth investing in a quality barrier and ensuring you have a perfect seal, if possible, across the whole footprint of the building.
Excellent, thanks, Michael. While I've got you, I can put this question to you if that's okay. Bruce Whitfield has asked on the YouTube chat, how reliable are the radon maps contained within BRE 211 on UK Radon website, and should these be relied upon when advising on radon protection?
So the radon maps are generated using British Geological Survey boreholes, every 1 kilometre grid section, and as well as Public Health England's radon testing on domestic homes. They correlate their information together to produce this map. This is only an indicative map. You can have elevated levels of radon anywhere in the UK. I wouldn't rely on the map too much. The only way to know what level you have in a building is to test. You can look at a brown area of a map and think you have high levels, but you may have very low levels. You can look at a white area and think there's no problem at all, and you can have high levels, especially if you have a basement anywhere in the UK. We can generate our own radon map as a contractor working all over the UK, all over Great Yarmouth, all over Wales, all over Portland, all over the white areas. Radon is in every single building everywhere. And the only way to know what your level is to test. Basically, it's a guide, it's an indicative guide. Yeah, so I wouldn't rely on it too much.
Perfect, thank you so much. Now we've had quite a few emails in already as well, which is great. We had one in this morning first actually from Chris Mew. Chris, hopefully you're still watching, and hopefully we have covered everything you've asked in your email regarding testing and things like that. If there's anything else that you do want to add to that, just get back in touch again and we can cover that one. So hopefully we covered that one for you, Chris. We've had an email in as also from Patrick Ford. Patrick has mentioned he's installing a 300mm raft foundation in an area where a radon barrier is required. Where is the radon barrier placed? Can it be placed under the 300mm thick raft foundation on top of the sand blinding on the prepared ground, which will be approximate 1.5 below the existing ground level? Sorry, Pam, I should have said to you first rather than springing that on you. Is that one that you can perhaps help Patrick with?
Yeah, thank goodness we've got fed these as well, so we've seen them coming in too. No problem. Yeah, I mean, it was touched on application and location of membranes within the presentation. So one of the biggest things is obviously we talked about there is making sure that you're not stretching that membrane, and affecting the integrity of it and you know, affecting potentially the gas resistance or putting in pinholes. So it potentially is possible. It might be a harder install because you're having to take it around footings, etc. But you know, please, Patrick, feel free to send over drawings to us, and we can have a look and you know, and make any comments and workability suggestions, etc. It might be that depending on what you've got above that slab, it might be more advantageous to place it above there if there's a screed, etc. But yeah, you can send us full floor build up and we can give you a bit of specific advice on that.
Perfect, thanks Pam. While I've still got you, Pam, can I ask you this one as well? Nick Cooper has asked on YouTube, are there parameters which govern the size of the building which requires protection?
I think it's not so much the size of the building, it's the quantity of radon that's there. Michael might correct me if I'm wrong here, but even the smallest building, if there is high levels of radon, will need a ventilation system in, or some way of getting rid of that radon from the building. So it's more what's there rather than the size of the building.
Perfect. Sue, if I could come to you now for the next question. This has been emailed in from Neil Brown, who is in Manchester. Neil asks, if installing a sump and you have decided to provisionally connect this to the pipework, which will be taken outside of the building and capped off just above ground level, what determines the necessity of connecting the pipework to an external fan and commissioning it?
Okay, so basically what you have there is essentially a passive sump system, which has the sump and the pipework obviously already in place. Generally that is really only suitable when the radon levels are relatively low. When the radon levels rise, this is like when you generally then need to attach your fan, which your fan is then fitted and it has to be running in order to draw the radon out.
Perfect, thanks Sue. Ian, if I can come back to you on this one, Gavan Rishi has sent in a message via Twitter asking, what differences or advantages are there with using a prefabricated sump over a site-made sump, say, constructed out of bricks?
Right, this could be a loaded question. I have to be very careful what I say here with Michael in the audience. It's all right, Michael, I'm with you on this one. Certainly, building on site is great. There's lots of examples you can see with installing bricks and paving slabs to create a depressurization zone underneath the floor. I've even seen examples or heard in the grapevine of examples where it's been recommended that rolling up chicken wire will provide a good enough void underneath the subfloor. I really hope that the last version of the chicken wire is a radon myth and just through the grounds or through pub talk, because I don't think that's very robust. Making it on site with bricks and paving slabs again is fine, but you're relying a lot on workmanship. So I believe that the best way is prefabrication. Obviously, Proctors are very much behind prefabrication. If you can do it in the factory, do it in the factory and then take it to your muddy building site with rain, etc. So prefabricated sumps, I'm a big fan of, and I would certainly recommend them wherever possible. Now, our guest today, Michael, might be able to further emphasise the advantages of having a prefabricated sump.
Yes, I've got one right next to me here.
Good, Peter.
We like props.
The props. They're just basically they're cheap and they are much quicker and efficient to install rather than building up your bricks and your slabs and piping it in. You just drop your sump in, you prefabricate the sump. It's ready to go. It's done. You just drop it in, pipe it in, away you go. It saves so much time. rather than building. As long as you have a void, technically, that's a sump. Any void is a sump. Brick built, a bread crate, anything, that is a sump. But a prefabricated, specifically designed radon sump is fit for purpose, cheap and efficient, and it's designed to do what it's designed to do, to reduce radon levels.
Perfect, thanks, Michael. Whilst I'm with you, if I could put this one to you as well, please. Brian Murphy has asked on YouTube, if radon is heavier than air, why vent at roof? Where do you vent safely? Is there a quick test 3 to 12 months? Is there a quick test 3 to 12 months is a long time? Sorry.
So when you extract radon gas from a building with a fan, up to 10 times the amount of radon you originally had in the building would be coming out of the end of the pipe. So for example, if you had 300 becquerels to start with, up to 3,000 will be coming out of the end of the pipe. So this pipe cannot be near a door or a window because that comes straight back in, contaminating the building. We've seen this before in basements where the fan's inside the basement with push-fit pipework. And the leaking pipes have then contaminated back the radon back into the basement, raising the levels up tenfold. So we always exhaust radon to above the roof line, away from doors and windows. Once the radon leaves the pipework, it rapidly disperses into the atmosphere. So that's the reason for the high point. You don't necessarily need to have your fan up the high point to extract all the way down to the sumps. If your fan is external, we like to install them low level for maintenance. You don't need to put a tower scaffold up to change a radon fan. You can just obviously do it at a low level. With regards to testing, the radon levels will fluctuate every day, every hour, every week, seasonally, usually higher in winter, lower in summer. This is why it takes 3 months to provide an annual average result in any building. You can do short-term 10-day or 3-week tests. These are only indicative. You can test for 10 days and the levels will be 300, and then the next 10 days they're 3,000. They really do fluctuate all the time. There are now digital monitors you can use, which will give you an indication immediately, but they become more accurate over time. So it takes, again, 3 months to give you the accurate long-term average. So there's no real shortcut to test for radon, unfortunately.
Perfect. Thanks, Michael. Ian, if I could come back to you with this one this is coming on an email from William in the Northeast. As we are constructing buildings to be more airtight, does this increase or affect the level of radon inside the buildings?
Thanks, Carol. This is a good one for me to answer because as Pam and Sue testify, my usual answer is depends. And, with air tightness, if you're increasing the air tightness, the logic is that you're not going to have as much air movement, people may think, and therefore you could have build-ups of radon in your building. However, air tightness, you need still air movement. You still need to breathe. With having an airtight building doesn't mean to say you're living inside a plastic bag. You still have to breathe and you still have to have airflow. So it could be argued that an airtight building has a purpose-made ventilation system, MVHR for example, that actually moves the air about better and therefore reduces the risk. If you had an existing building on an existing foundation and solar with a subfloor vented and increase the air tightness there could be an increased risk by increasing the air tightness because you've changed the dynamics. And just as we've said in lots of other previous webinars, it's all a balance of heat, air, moisture, and now today we're going to have to think about radon. So heat, air, moisture, gas. I don't know what the acronym for that is. It's not quite as good as HAM principles, but I'm sure marketing could come up with a clever acronym for it. But yes, you do have to take it into consideration. If you're improving one aspect of the building, then you can increase the risk in other areas. So you've got to take that into consideration. With the older buildings, you might have a leakier floor that would allow the gas to come in and it could get trapped. With the older buildings, with rough foundations, etc., it's less likely to come into the building. So my answer is depends, but be careful and always speak to proctors because we can take it all into balance.
Exactly. We've said it before. Please don't think our answer of depends is a cop-out in any way. More often than not, there is not a one answer fits all. So pick up the phone, drop us an email, engage in an online web chat, and our team will certainly go through everything with you in more detail and give you accurate advice. Right, let's move on. Okay, Pam, if I could bring this one back to you. This is something, I think this is quite relevant here. There's two quite similar here, so Pam, hang with me. When other gases are present alongside radon, such as methane, which should take priority?
All ground gases need to be considered. They all have their own set of parameters and dangers and effects on humans, you know, on the people, the occupants of the buildings. There is obviously guidance in BS 8485, if you want the full name, 2015 Annex 2019, but it does take precedent over dealing with methane and CO2. Methane, obviously, if something goes wrong, it's explosive, it's quite obvious and quite a dramatic result. CO2 is an asphyxiant, so again, that can be quite an immediate negative death potentially, or unconsciousness. So they tend to have had a lot of focus on them in the past. Radon is, as has been touched on before, it's a silent killer. It's the one that can have significant long-term health implications. So it's important. What you do find is that the requirements for controlling methane and carbon dioxide, the level that those membranes have to be at, will also help resist radon coming into the building. So they will act also as a radon barrier, as well as a damp-proof membrane, as well as a barrier against CO2 and methane.
Perfect, thanks, Pam. I'm going to come back to something similar on that one, but I want to just cover this question that came in. It's quite similar from Bob. Bob Eden has asked on email, does the radon protection approach also hold good for methane risks?
Yeah, well, when you switch that, if you look at the sort of the minimum requirements, the requirements for radon with methane, it is unlikely that if you just put in radon protection measures that it would work for methane. Again, it depends on what's there, what's on the site, what you're putting in terms of membrane, ventilation, slab, etc. to mitigate it. It's not as such an easy switch over as your methane and CO2 will do radon. It's not as simple to say your radon protection will do methane and CO2. Obviously, Michael gave us a brilliant explanation about why you ventilate radon at high level. Things like carbon dioxide and methane are ventilated at low level, so they're slightly different. So it's probably not best to rely on your radon protection to do your methane and your carbon dioxide, because there's some quite specific guidance around that.
Perfect. We, just to let everyone know, we actually recently posed a question to some of our customers. We asked a group of customers, we asked them what they thought was the most dangerous ground gas that we have to deal with. And unbelievably, only 10% came back saying radon. Perhaps this is something that the panel can maybe add their additional thoughts on. Michael, maybe we could go to you first on that one. What's your thoughts with that?
Not really surprising. Generally, we find the awareness of radon is low, so not a lot of people have heard of radon. They don't know what radon is if you speak to someone about radon gas. Everyone's perception is different. It's like if you speak to a smoker, you can get lung cancer if you smoke. Well, I've smoked for 50 years and I'm fine still. Everyone's different. I like to liken radon to asbestos. If you mention asbestos to somebody, they know what asbestos is. You can have problems 50 years down the line after inhaling asbestos. It's a similar thing to radon gas. You can't see it, you're breathing it in, and it can damage your lungs over a long period of time and cause lung cancer. So I think there's two things. The awareness is low, and not a lot. And I leave it there. Yeah, the awareness is very low across the country on radon, especially in compliance managers and health and safety. Yeah, I'll leave it there.
Yeah. Very surprising. Anybody else want to make a comment on that one?
Yeah, I would echo exactly what Michael said there. I don't think there's enough exposure on radon. It's a bit of a soapbox I get onto with this one. You know, it is the silent killer. Unfortunately, you know, people don't realise that the reason that they've got cancer is because they're potentially living in a house that is affected by radon. You know, the seminar said earlier that there was over 1,000 deaths a year in the UK can be attributed to radon. Yet it doesn't get the exposure or change of regulations, and until recently, we're still saying 12,000 gauge polythene is adequate, and that's the only form of protection you need, which I've already mentioned my opinion on that. You know, put that into context of the deaths in the UK compared to fire in the house. There's a lot more attributed to radon gas than there will be fires in buildings. But yet, brilliantly, for all the right reasons, the fire regulations are changing and improving. But radon just seems to be slipped under the ground, if you excuse the pun. But you know, it needs to be taken into consideration. It needs to be taken more seriously. It's easy for us to say that, but yeah, definitely from an holistic point of view, as we've talked about before, I think radon needs to be considered more seriously than it is at the moment.
Yeah, definitely. Okay, Sue, if I could maybe bring this one to you, if that's okay. We have an email in from Nigel White. Nigel has said, do you have details for the radon barrier at door openings with level thresholds?
Yes, we do have details for that. It's fairly easy to detail a level threshold, and we can send over some information, a detail showing that if he gets in touch and lets us know his contact details.
Perfect, thank you. Okay, Michael, if I could come back to you with this one from Dave McGrath on YouTube. Dave has asked, how do we deal with existing homes built pre-1980, for example?
Well, obviously all buildings are different. So all buildings need to be looked at individually. You can work on buildings 300 years old up to new builds. We can retrofit radon systems in any building, pretty much. You can install another prop. We've got mini sumps you can install from outside. So you can excavate a pit outside and cordon underneath the concrete floor, which is a similar way of building in your protection at new build. Instead of having the sumps already in the ground, you just pipe them in from the outside. So you can extract the gas from the ground in any building if they got a solid floor or concrete oversight. There are a number of techniques we use for remediation. It depends if it's a bank, if it's a school, a house, a basement. There's lots of different techniques. Yeah, there's lots more. There's too in detail to go. Too much to go into detail. I'm stumbling over my words. But yeah, every building's different. Even if you have a row of terrace houses, each one will be looked at differently.
Perfect. if I could stay with you, Michael, there's another one come in from Philip Campbell on YouTube. Philip has asked, how long do the monitors need to stay in place?
So the track etch radon detector monitors need to stay in place for a minimum of 90 days, which is 3 months. That enables the testing lab to give you your annual average result. So you can have short-term detectors, 10 days, 3 weeks. They're the same detectors, they're just sent back earlier, but they will only give you your raw result, which is an indicative result. So it needs to be in, if you're testing a workplace especially, the workplace action level is an annual average action level, 300 annual average. So you need to have a 90-day test to provide your annual average result.
Okay, let's move on now. I've got this one for you, Ian, if that's okay. Jeremy Fox has sent in an email. He has asking, are there advantages and disadvantages when comparing active systems against passive systems when venting radon?
Thanks, Carol. Glad you came to me after Michael. I don't have any props, so unfortunately I won't be as well versed as Michael on that one. But certainly I do have an opinion on active and passive ventilation. The passive ventilation can work well, depending on what the risk of radon is and what level that is. So your subfloor void, your timber floor, suspended timber floor can be perfect and adequate depending on what the risk is for the levels of avoiding the gas coming into your house. I remember my granny phoned me once to tell me that she'd had a radon test done. She's in the Cheviot Hills of the Borders, and the house she was living in was deemed to be at levels above the action, the required action level. So she phoned me with a great panic in her voice as to what am I going to do. I've heard about radon sumps. What can we do? Now, I managed to calm her down and said, Granny, you've been living in that house for 50 years. I think you're going to be okay, but I'll come and have a look. So I went and had a look, and she had a timber subfloor ventilated. But unfortunately, the bricks were blocked. And it was quite an intricate metal that was put over the bricks that was blocking the vents. I asked her what had happened here, and Granda told me that Granny had asked for them to be put in to stop mice coming into the building. So I said, that's a great idea for stopping mice, but maybe not a great idea for keeping radon into the house. So we took the vents out, and 3 months later, she got the all clear in terms of becquerel levels that were at acceptable levels again. So the panic was over. But the point is, you know, the vents are in there. So as long as you're maintaining the vents and making sure they're right, that kind of passive ventilation, depending on the levels, can be okay. Personally, I like an active system, or at least a design system that's in there that you can attach a fan to at a later date. You know, similar to what they do in Southern Ireland, where just accept that you may have a risk, build it in when you're building the building, and then if you need to, put a fan in at a later date. So, with the greatest respect to my granny and granda and their mice problems and radon problems, you know, you've got to take everything into consideration. But if you design it in there that you can actually put a fan in and take the active situation, I think that's a better way.
Poor granny and granda.
Michael, have you got a comment? Or have you got granny and grandas that have got problems with this?
Well, passive systems where you have a sump installed and a pipe leading to the outside, if installed correctly with the outlet right at the eaves level of the house, they can work. They say it can work. as a company, we don't really recommend passive systems in that sense. We have seen lots of people install an external pipe to under the floor with a short 2 feet or 1 foot of pipe with a cowl, which is venting at low level. Now, if any wind blows down this pipe, you're going to bring more radon into the building. So we always, when we design radon systems, we design them to be active. Obviously, we're working with high levels of radon. If your levels are maybe just below or just above the action level, you can get away with passive systems. I'm not really talking about just air brick vents, because that's obviously just air brick vents to ventilate the floor. An actual system installed, just a pipe with a sump. If installed correctly, they can work and reduce levels, but not obviously for anything over, I'd say 300 becquerels, maybe less. You're all depending on wind pressures, on the weather. There's so many variables where if you have a fan, you're just extracting constantly. It's the safest, surest way to extract.
Michael, if I could stay with you again, Leighton Still has put a comment into YouTube. This is one you might be able to help with. What is being done to educate contractors on their knowledge on radon protection measures? We've touched on this before. Many believe 1200 gauge DPM alone is suitable, with no improvement for action levels depending on site location.
The short answer is not a lot has been done to educate contractors. We offer training. We offer on-site demonstrations to contractors if they have a large project and they're installing lots of sumps and barriers and pipe work. We will supply the products and explain how to install a sump, what to surround the sump with and cover it with. Generally though, unless building control or the architect specify radon, the contractor is not going to do anything with radon. I've actually heard of a builder a while ago. He spoke to me, he said, I'm not sure how a radon sump works. So I dug a pit, I put the sump in and buried it. So I don't know how it's going to work. I said, did you put a pipe to the outside? Oh no, I was just told to put a sump in. So that's the sort of thing we're up against. Radon is a specialist subject. So I would always obviously recommend a specialist at least giving advice and guidance to the contractor, or better yet, to install radon protection and remediation systems. Training is always available to all contractors.
Fantastic, thanks Michael. Let's come back to you now, Sue, if I can. Catherine Letchford has messaged us actually via LinkedIn with her question. What is a typical cost of a radon system?
Ooh. Okay, so that will depend on a lot of things. Obviously, the size of the building, the type of system that you're actually using, various aspects. There are examples of costs on the UK Radon website, and that gives like approximately costings for different types of protection measures. We ourselves can obviously give costing information related to our membranes and ancillaries such as like the sumps and pipeworks, etc. The other thing that has to be considered then, I suppose, is the running costs, especially if you have like the fan fitted. I think that's typically around about £2 a week running costs for a fan, but it's not a huge amount considering that obviously it could be saving lives ultimately.
Perfect. That's it. You can't really put a price on a life, can you? Sue, can I stay with you if that's okay? Billy Murphy has put a couple of questions in. I'll give you this one. For a cavity wall construction with an internal and external 4-inch block, does the inner wall require a DPC when using a dual-purpose barrier acting as radon and DPM, given the radon barrier crosses the cavity?
The radon barrier, it does cross the cavity, and obviously that protects against the ingress of, like the gas rising up into your cavity. You would still always use a structural DPC in your construction as well. And again, like I said earlier, we do have standard details, which we can send over just to show those, show that example.
Perfect. Sorry, Sue, if I can just give you Brian's other question that I can see that's here. Granite aggregate can get into any concrete. So is any building affected? Granite claddings and floors?
I suppose potentially any building can be affected if it has the type of stone, etc., that that will give off radon gas. So yes, that is a potential. You'd obviously need to look at it in a lot closer detail just to see exactly what the effects are, but potentially. Perfect.
Thanks, Sue. Okay. Michael, if I can bring this one back to you. Nikki Hutt has asked on YouTube, perhaps you can comment with this. I would just clarify that PHE recommends 3-month tests. On paper, 12 months is ideal, however, not practical, hence the application of seasonal correction factors to measurements. Do you want to add any extra comment on that?
Yes, so the minimum is 90 days, 3 months, to provide your seasonal variations. The lab will add a calculation to your results to give your annual average. The longer the detector is in place, the more accurate the results will be. Generally, the TrackX radon detectors will expire after 12 months. So you can leave them in for 12 months as long as they're placed immediately, retrieved immediately. You'll get the most accurate result the longer it's in for. But you can test all year round for 3 months and have the seasonal variation factor to give you an annual average.
Excellent. Sorry, I've got they're firing in here thick and quick. If I could stay with you again, Michael, Brian Murphy has another question. Do you need a 3 to 12 month test after completion of the barrier to prove it works?
Yes. This is something we've spoken to Building Control in Somerset. We did a presentation to them, giving them an education on radon gas. They actually told us that they were telling people not to test after installing radon protection, which is obviously just confounded us. You don't know if your protection's worked until you test. The message is obviously just test. If you install protection, a barrier, just a barrier or a barrier with a sump, once the building is completed and occupied, then you need to test to see what the levels are. You will always have some radon levels in there, even if your barrier is perfect, if you've got 10 sumps, etc. You will still have some radon gas in the building. What the level is, you don't know until you test. And then if the level's high, you remediate, activate the sumps. If it's low, continue monitoring. Even after you have reduced your radon levels, you should then continually monitor every year, every 2 years, just to ensure your levels are low. It's about managing the radon levels going forward, and definitely you don't ever install a system and fit and forget that's it. It's a management process that's ongoing. Radon is never going to go away. If you've got any radon levels, it will always be there.
But that's actually a really interesting point. Sorry to butt in. It's CO2 and methane is kind of more like a fit and forget. You put it in, it might be you have to clean out your vents every year, make sure they don't get clogged up, or make sure they're not covered. But the maintenance and the ongoing monitoring for radon is something that we probably don't think about as much, and is obviously a critical aspect of it, because radon, being a radioactive gas, is going to be there for thousands upon thousands of years, whereas you could get a situation that if there's like a pocket of gas with with methane or carbon dioxide, that could dissipate and reduce over time. It's not going to reduce over time with radon in our lifetimes. So thank you, Michael. That was really interesting.
Certainly was. Ian, if I can come back to you here. Dave McGrath is mentioned on YouTube. I'm not sure if actually, I'm trying to keep an eye on everything. I'm not sure if somebody's actually maybe has answered them back here. Any papers that discuss the physics, radon is emitting ionizing electromagnetic radiation, which will penetrate the ground and fabric. What is the actual gas chemistry? Does anyone know?
Yeah, I saw that one coming in, Carol. I think Nikki Hutt has solved my problem by providing a paper on passive remediation of radon in UK homes. So thanks very much, Nikki. You've maybe helped me out of a spot there. I was really struggling with that one. Whether anybody else was ready for that one on ionizing electromagnetic radiation.
Radon has alpha, beta, and gamma radiation. It's the radon daughters that are actually harmful. It's not the radon gas itself. It's the alpha particles in the radon gas, which is an ionizing radiation. I'm not too sure on the electromagnetic side of it, but it's the alpha particles that the basic format is you breathe in the alpha particles, they can damage your lungs, make a cell mutate to a cancerous cell. That's how the most basic format is how you can contract lung cancer. Radon gas can penetrate through the fabric of buildings easily. That's why we've said there's no such thing as a radon barrier per se, because radon will still penetrate through the barrier. The idea of a barrier is to not stop the gas coming through, it's to prevent as much as possible coming through. You'll always have some dissipating through the barrier. PHE before have explained it as almost like a river effect. If you have a blanket cover of the barrier, for example, if you had 20,000 becquerels in the ground and you have a barrier, you may have 200 coming through. So you're restricting the draw through the ground. But yeah, there's alpha, beta, gamma radiation in radon gas. And you can go really into detail on the daughters and the half-life, and that's how the health implications come into effect.
That's a really good answer. Thanks, Michael. I think we're all learning here by having you on the panel today. It's a really good point about the barrier. It's probably not the right terminology, a barrier, because that gives people the impression that it just stops everything. Personally, within Proctors, we have a project at the moment, but it's regarding methane, where they're talking about a methane barrier, where it's assumed that by using even a Proctor membrane, that all the gases are going to be stopped. Now, we are having to educate even the engineer that the terminology barrier is reducing to acceptable levels the gas that might be able to get into that building, rather than actually stopping it completely. Buildings have to go on top of any of these membranes. You can't put the building on skyhooks. So, the building has to be built, and you can only do your best to reduce the risk, rather than try and blindly think that you can completely barrier any gas coming in. So you reduce the risk as best as possible. So thank you.
If I could come back on that again, if you were to test a cave or a mine, for example, and there's lots of humidity in the air, Public Health England will send out their detectors inside a heat-sealed polythene bag, which is 1200 gauge, and you don't open the bag. You leave that in the bag to protect the detector from humidity. That's still recording the radon levels. It's passing through the barrier into the detector. So that just proves the point that it doesn't stop it. It doesn't stop radon at all. It'll still penetrate through.
Yeah, I love that. I'm definitely going to use that 1200 gauge bags for measuring radon.
I've got one in the office, but I can't find it. I would have a prop again otherwise.
Won't show us up by most props, but certainly if you've got one, I'd love to see one.
We always like a prop, but Michael, you have shown us up today.
Indeed.
Pam, if I could come back to you with this one. Ali in Aberdeen has emailed in asking, Do radon membranes require verification under Syria C735, similar to that for methane and carbon dioxide?
It's a great question. And I'm seeing in the feed, and I see that John Sparks from GeoShield has joined us, and he is a big exponent for verification on radon membranes. I think what we're discussing today and the conversations that we're having is showing that it should be verified in exactly the same way as methane and carbon dioxide should. You know, it's as dangerous a gas, if not potentially more so. Verification is always good. Verification means that you have a second pair of eyes or a third pair of eyes looking over the install, making sure that you don't have those pinprick holes, those, quite frankly, in some cases, massive, great big rips or unsealed joints, etc. So although it is an essential part of it, and it's an integral part of it, it's not allocated in the same way as it is in 8485. So 8485 say that to get 2 points for your barrier system, you must have verification in place. There's not that same level yet in the radon guidance. I honestly think that moving forward, we have to put more of that in place. I think it should become an integral part of it. But obviously that's going to be led by guidance and dictated by guidance, although there are going to be a lot of people out there that are taking it seriously, are taking on advice like, you know, that which Michael's company provides, and will be doing verification and checking on site. It also highlights why you should be looking at using qualified installers, people that understand the risks.
Yeah, perhaps, Michael, do you want to put any further comment onto that one?
Yeah, I'm all for verifying radon barriers. Not to be confused that if it's verified, that means no radon's coming through. It means it's obviously sealed. We've seen too often where radon barriers are lapped up the walls, not sealed. They've cut the corners. I'm all for verification to have an independent person say, you've not sealed this barrier properly, and he's improving. That's just a good thing. But it's not, the verification cannot be confused with, right, it's verified, that means we're not going to have a problem with radon.
Yeah, it's that independent assessment of the install, isn't it? Making sure that the entire floor is covered. Doesn't mean to say that, you know, as we say, it's looking at making sure that the levels within our dwelling areas are at a point where it doesn't trigger health issues.
We've had a recent project in a new building, which has won awards for its design. It's got a radon barrier installed, but they've just cut a section out for all the electric cables to come through. And now they're wondering whether levels are still high. Because I took the photo up, I was like, well, there's no barrier here. It needs improving all across the board.
Absolutely.
Yeah, absolutely. There's a good few comments have come in there. Thank you to everyone. John Sparks, as we said, when installing a radon protection system under BR211 guidance, make sure that the Appendix B is completed to allocate contractual responsibility. Building control and your local authority will ask for this. There's another one there from Tracy Gooding. Building materials with granite aggregate will emit a limited amount of radon, and the room would have to be small and with very limited ventilation to get a significant level of radon. There are no regulations that cover radon exhalation in the UK yet. Sorry, I've got my glasses on, I can't read yet. The source below the building will almost always be the main one. Okay.
So, if you don't mind, I can jump in on that. In Cornwall, lots of the walls and fireplaces are made of granite, so you have high levels. It's very difficult to pinpoint where the radon is coming from, whether it's from the floor or the wall, for example. But you're also going to have some radon coming through your water supplies, very low levels. So if you do a radon test, you're not going to know where it's coming from. It just says, in this room you have X. You can't say it's coming from that granite stone in the wall or from the floor. There are some projects looking at the aggregate that's used in below buildings that may emit some radon gas, but there's no real remedy to that. It's, you look at the building and you remediate the building rather than, okay, we've got granite stone under here, let's remove the granite stone and put limestone instead. So yeah, there's no way of pinpointing exactly if it's coming from this stone or from the ground.
Yeah. UK Radon Association have just commented, agreed. The best verification you can do is a radon test within the property on completion. The thing that matters is the indoor radon concentration that the occupants are going to be exposed to. Which, Michael, brings me on to another question that we have here. Graham Castle has asked you, once the building is complete, what is the next phase for radon gas?
So once the building is complete and occupied, so not empty, needs to be occupied with doors and windows being opened, heating on, heating off, that's then when you need to test for radon gas. Whether you have protection built in or not, I would recommend test. A little bit like COVID, just test, test, test. You're really going to know what the levels are. And then, so basically it's a three-phase approach. You build your protection in, you test for the radon gas, and then remediate if necessary. It's as simple as that, 3 stages. If you don't test, you don't know if the protection's worked. You don't know if your levels are really high. It's just unknown. There's no point in guessing. You can't see or smell or taste radon gas. So the tests aren't very expensive. So the next phase is test, remediate if necessary. And like I said before, if your levels were high and you've remediated, make sure your fan is maintained, it's always working. As soon as the fan's not working, the levels will raise back up again. So continually monitor every couple of years and make sure your systems are always maintained and working.
Can I ask a question on that, Michael? Sorry. Obviously I understand the sort of the basic test, the monitoring system that goes in. Is there such a thing developed or available that is like, I suppose, like a smoke detector or a carbon monoxide detector that's in all the time monitoring, and then will give an audio alarm or something like that if that level gets too high? Or is it a case of that's not, as you said earlier, because the natural variations, it's not a suitable way of looking at it?
There are digital monitors. We've teamed up with Airthings, who supply the digital monitors, which are called Airthings Wave radon monitors. They look like smoke alarms. You can screw them to the wall. You have an app on your phone, and you can have a dashboard on the computer. So you can look real time at your radon levels and see the peaks and troughs. Okay. The only issue I have with this is I have clients phoning in saying, my levels are 300 today, and I'm really worried. And the next day they were 20, and then they were 200. They vary. It's the long-term average that you need to look at.
Yeah.
Radon gas is part of our annual radiation dose. It's about half of our radiation dose from man-made and natural sources. And it's your exposure over the year that you need to manage your risks. So yes, there are digital monitors and they're great. You can see instantly on your phone as an app. They also have, the Wave Plus has CO2, VOCs, humidity, pressure, so use indoor air quality monitoring, not just radon. There's different products. But just don't get carried away. I've got one in my house and I'm always looking at the CO2 levels. Radon levels are 9, which is great, but I'm always thinking, oh, CO2 levels. So it's like a jungle now with indoor house plants bringing the CO2 levels down. But you need to remember it's the long-term average for your health risk, to bring the risks of health down.
Thank you.
Thanks, Michael. Just getting to the end of this now with questions. I've got one here that I'd like to just open up to all the panel here. do you think BR211 is still fit for purpose in 2021? What's your thoughts on that? Silence was the answer.
It's a good one.
Well,
Generally speaking, yes, I think so. If you take a standard building with a solid floor and you have a barrier and a sump capped off, then you're pretty much treated. Obviously, all buildings are different, and it's just a guidance, and you can always improve as you go along. I think the BR201 is not the first edition; it's been improved on before previous editions.
I would say, Michael, I would echo your thoughts there. I think it's a great document. It's got some really good principles in there. I personally think it should be updated. I go back to my earlier comments on 12,000 gauge, 1200 gauge polythene. You know, I think every standard should be constantly looked at, not just radon, but look to see if it can be improved. There's always new fabrics coming out, new materials, new solutions, new sumps and things. So you should always look to see if you can improve it. And I think 211's come on well from the days of chicken wire and paving slabs on top of bricks. But I think it should be looked at again. And my particular thoughts, as you would all probably guess, is looking at the gauge of material reinforced, being a bit more robust, so we can offer clients real good solutions. So I think it should be done.
Yeah, I agree. And actually just looking at the feed here, Tracy from Public Health England has said that it is being reviewed, which is great news. And the UK Radiant Association has obviously been involved there. Sorry, Carol, I'm butting in, you doing your job here. But, you know, and looking at sort of trying to bring it in line. So it sounds like we are getting an update, which is brilliant news.
Continual improvement is always good, isn't it?
Yeah, that's it, exactly. Yeah. I mean, it's a great document, but...
Brilliant, excellent. Thank you so much. And certainly thank you to everybody who's been adding in comments there, especially, like you said, Public Health England there. Their input has been fantastic today. I think that's pretty much summarised everything. I think we've covered everybody's questions. If there's one that I've missed for some reason, my apologies. We will go back through everything just to make sure it's all been covered. If you think about anything after you go away today that we have missed or you'd like to just ask, just drop us an email or pick up the phone, get in touch, and we will certainly look into it for you. Thank you very much to our expert panel today. Very special thanks to Michael for taking the time out of his busy schedule to be with us.
Thank you.
Please register now for our next webinar, which is covering air tightness solutions for high-rise and modular construction, taking place 2 weeks today. Don't forget to subscribe to our YouTube channel and get information on all future content and leave us some feedback. That's pretty much it from me today. Thank you again for joining us once more. Please look after each another, keep safe and enjoy the bank holiday weekend. I hope the sun shines wherever you are. Take care, everyone. Goodbye.
Bye.
Right.